Something genuinely exciting is happening in the world of car brakes, and it might not be getting the attention it deserves. Chery Automobile, the Chinese automaker that has been quietly building momentum for years, is about to do something no car company has ever done before in mass production. They're putting a fully electronic mechanical braking system into a real passenger vehicle that real people will actually buy. No hydraulics, no fluid lines, just electrical signals telling each wheel exactly how hard to stop. The car is called the Exeed EX7, and if everything goes to plan, it will be on roads in the first quarter of this year. To understand why this matters, it helps to think about how brakes have worked for essentially the entire history of the modern automobile. When you press the pedal, you are compressing hydraulic fluid inside a sealed system, and that pressure travels through lines to each wheel where it clamps the brake pads against the rotors. It is an elegantly simple idea that has served drivers well for decades, but it also comes with real limitations. Hydraulic systems have inherent delays, require fluid that needs maintenance, and involve pumps, reservoirs, and extensive piping that add weight and complexity to every vehicle ever built. Electronic mechanical braking throws that entire architecture out. Instead of fluid doing the work, electrical signals carry braking commands directly to actuators at each wheel, which then generate the mechanical force needed to slow the car. The communication happens at the speed of electricity rather than pressure propagating through fluid, making response times almost impossibly fast by comparison. We're talking milliseconds, and in a braking situation, milliseconds genuinely matter. Li Shuiyong, executive vice president at Chery, confirmed the news and made clear this was not something the company rushed. The engineering team spent 3 years working through problems that have historically kept brake-by-wire technology out of production vehicles. Getting response times down was one challenge. Achieving precise control over braking force at each individual wheel was another. But the most demanding part was ensuring the system would hold up reliably over years of real-world use, in every kind of weather and under every kind of driving stress imaginable. That deserves emphasis, because safety validation for braking is not like testing any other automotive technology. Failure is simply not an option. Engineers had to design in layers of redundancy so that if any single component failed, the vehicle could still stop safely. They developed advanced control algorithms, high-precision actuators, and electronic architectures built around the assumption that something could go wrong and the system needed to handle it without the driver ever noticing. That kind of engineering discipline is genuinely difficult, and Chery's confidence in putting it into a production vehicle means something. The stopping distance improvements are one of the most immediately tangible benefits. Because the system reacts faster than a hydraulic circuit, braking begins sooner after the driver's foot moves. In everyday driving, that might be barely perceptible, but in a genuine emergency where every fraction of a second counts, earlier braking initiation can be the difference between a close call and a collision. The Exeed EX7 itself is a genuinely ambitious vehicle beyond its braking technology. It sits within Chery's premium Exeed division and was previously known as the Exlantics ET7 before a rebranding exercise earlier this year. Regulatory filings submitted to China's Ministry of Industry and Information Technology last November gave the first detailed look at what the EX7 would offer. The vehicle comes in 2 powertrain configurations, a fully battery-electric version and a range-extended variant that pairs a combustion engine with an electric drive system. The pure electric version is built on Chery's EOX high-voltage platform with a dual-motor all-wheel drive setup. The front motor contributes 123 kilowatts, while the rear handles 230 kilowatts, bringing total output to 353 kilowatts. That is a meaningful amount of power for an SUV and should translate into strong acceleration alongside confident high-speed stability. The range-extended variant uses a turbocharged 1.5-liter petrol engine, though not in the conventional sense. The engine never drives the wheels directly. Its entire job is spinning a generator to produce electricity, feeding either the drive motors or the battery, depending on what the energy management system decides. It produces up to 115 kilowatts in this role, enough to sustain battery charge during motorway cruising. Battery options for the range-extended models sit at roughly 39.8 kilowatt-hours, delivering between 182 and 203 kilometers of pure electric range before the generator activates. The fully electric version carries a 97.682 kilowatt-hour pack with an estimated total range of between 682 and 726 kilometers. The electronic braking system works as part of a larger integrated chassis architecture Chery calls Flying Fish Chassis 3.0, which brings braking, suspension, and traction control into a coordinated platform where each component shares real-time information with the others. When the brakes come on hard, the chassis system communicates instantly with suspension and traction management to keep the car balanced rather than allowing weight transfer to destabilize the handling. On slippery surfaces, braking force can be distributed between individual wheels with a precision that hydraulic systems simply cannot match. Inside, the premium ambitions of the Exeed brand are immediately apparent. A 30-inch integrated display sweeps across the dashboard, handling navigation, entertainment, and vehicle settings, while a separate floating LCD instrument cluster keeps driving information directly in front of the driver. The front passenger seat includes a zero-gravity configuration to reduce fatigue on longer journeys, a feature historically associated with significantly more expensive vehicles. A panoramic sunroof runs the length of the roofline, and the interior pairs black and brown finishes throughout, with a dual-spoke multifunction steering wheel completing the upscale feel. Looking at the EX7 in a wider context, it is hard not to feel that something meaningful is shifting in how cars are engineered. Electronic mechanical braking is not an incremental improvement. It is a genuine architectural change that only becomes possible when a vehicle's systems are already built around electronic control rather than hydraulic hardware. The rise of electric vehicles has created exactly the conditions needed for brake-by-wire to finally become viable at scale. The tighter integration between sensing, decision-making, and actuation also makes advanced driver assistance systems more effective, since the gap between deciding to brake and physically braking narrows considerably. What Chery is attempting here is not a small thing dressed up to look bigger than it is. Introducing the world's first mass-production electronic mechanical braking system alongside competitive electric range, an integrated chassis platform, and a genuinely premium interior is a bold undertaking. Whether the EX7 becomes a commercial breakthrough or a quiet engineering milestone that others build upon, the fact that it exists at all marks a real moment in the history of how cars stop.